Yes, now it is.
Yes, slow.
Bro, I'll do the introduction, I guess. Welcome to ESMARConf2023 and this introduction to GitHub workshop. It's being live streamed to YouTube, so automatic subtitles will be available shortly after the event, and we'll work hard to get these manually verified as soon as possible. If you have any questions for our presenters, you can ask them via the ES Hackathon Twitter account by commenting on the tweet about the session. And if you register for the conference, you can comment and chat with other participants on our dedicated Slack channel. We will endeavour to answer all questions as soon as possible. This workshop is being live streamed to YouTube and actually has a group of participants taking part live, so a very warm welcome to you all. Those participants can ask questions directly in the Zoom Q&A, but we'll endeavour to read them out for those following along on YouTube. Our workshop presenters are me. I'm Chris Pritchard. I work at Nottingham Trent University. We've got Matt Grainger, who works for, and I've instantly forgotten, so I'll let him introduce himself, and Matt Jones from Exeter is fielding questions. Sorry, Matt.
That's okay. Yeah, so I'm Matt Grainger. I'm based at the Norwegian Institute for Nature Research, which is in Trondheim in Norway.
Excellent. So should we get started?
Yeah. Excellent. So I'm going to talk about GitHub today. This is the basic introduction to GitHub. I'm leading this one because I am the basic person in the team here, and later on Chris will give you the fancy pants advanced version. So I'm going to try and take it slowly. I'm going to assume that the people don't know too much about GitHub and integration with R and RStudio, but yeah, it's a fairly low-key stuff today, so I won't hammer you with lots of different things. And the main thing I'd like to get done really is to give you guys a chance of having a play around and trying it yourselves if you can. So that's the main thing. But so what I'll do, I've got like 6 or 7 slides, just an introduction, and then after that I can go through how in practice you might be able to use RStudio to connect to Git to make a project and do some of the things that are useful within there. We won't be using the shell, which is the coding part of the using Git language to GitHub. We'll be using all the inbuilt RStudio tools. So later on, if you're interested in the shell, then that's the advanced stuff we can have a look at. So I've got some slides which I'll share now, if I can work out how to do it. Share. So you should be seeing an introduction to GitHub slide. Yes, thank you. Just one warning, I'm at home now, so my internet sometimes cuts off. So if I freeze in a funny position, please tell me once I come back again. I've done that. Let me put this to full screen. So this is workshop 7 from ESMARConf2023, and it's introduction to GitHub. Before we can even start to use GitHub, there's certain things we have to do. So one of the things is that you need a GitHub account. So they're free to get and very easy to start up with. There's a link there, which I'll put into the chat in a second, which has the way you can get your GitHub account. You need to download Git as well. So you search online and find Git and download that to your computer. And I'll explain what the difference between Git and GitHub is in a second. You need R and RStudio, obviously, because you can't use RStudio without having RStudio. And then there's a really good blog type of thing from use this package that tells you how to set up your account between your GitHub account and your RStudio. So it's really useful to have a look at that. And let me just put those in the chat. Keep pressing the wrong button.
I'll do that if you want, Matt. Then
Okay.
You can carry on.
Brilliant. So what we want to do through the workshop is to understand the concept of version control. understanding the basics of linking RStudio to GitHub through your work. Understand committing changes to RStudio and pushing those to GitHub, and then pulling changes back down again. And I'll explain all these terms soon. Understand pull requests, and understand other tools for in GitHub itself. There's these extra tools like issues and discussions and reviews, which help with collaboration with other people. So what is Git and what is GitHub? So Git is the open source version control system. It was created by this guy, Linus Torvalds, in 2005. And what it allows you to do is to track changes, basically, of files over time. So the idea was for it to be used for coding, so software development, so open source, open software development, and it allowed people to track the changes that happened over time. It's useful in that format still for code, but people increasingly use it for other things as well, for other document types. Although people often use it for data, it's not actually designed to save data. It's not a long-term safe repository for data. And also, when you put like an Excel file onto Git, it actually struggles a bit to maintain version control with an Excel file or a CSV file. So I would recommend putting your data somewhere else. But like a small amount of data is probably okay, but these sort of big database probably wouldn't work. So Git is this version control system. GitHub, as the name suggests, is a hub for Git. So it's a website that contains different repositories, so places where a collection of files that are tracked by Git. So GitHub itself is owned by Microsoft, just recently taken over by Microsoft. They seem to want to keep it open, so which is really good news. But there are other options that have a very similar approach. So I talk about GitHub today because we know when we work with GitHub, but there's GitLab, which has a very similar approach. And there's a few other types of products that are very similar. Bitbucket is another one that's very similar. So you don't have to just use GitHub if you're vehemently against Microsoft, then you can maybe choose something else as an approach. They basically do the same thing. They allow you to store versions of your code in a repository, so a place where all your code and your changes are maintained, which is stored on your computer, but also in the cloud, so on GitHub's website. So why use Git and GitHub? Well, GitLab makes it easier for users to interact with Git. Okay, so Git is the language or the system that was developed, but it's, unless you're a computer scientist, like Chris used to be in his past life, then you don't really understand a lot of the way that Git works. With GitHub and GitLab, these things are just a little bit easier for people who don't have a full coding background. There are some coding to involve with, but it makes it a lot easier. But as I say, the most important reason for using Git and GitHub is this version control system. So version control, all that is you're going to use is that sort of track changes, as I said before, for code and other files. So I like this diagram from the Turing Way project. About open science, but they're one of these issues about having several final drafts of your document. Okay, so if you have a writing a thesis, for example, you might have thesis final 1, thesis final 2, thesis final 37. Okay, and you end up with lots and lots of documents saved that are exactly the same, but with minor changes over time. And then you maybe get a bit lost at, like, am I on thesis 37 final? Am I on thesis final 37? Oh, I don't know. So maybe you need to try and work out which is the latest one. With version control, it just tracks the project history, and basically it's a lot cleaner. So you have one document and the versions are saved, but actually you don't actually see that unless you want to go and find the different versions. And if I make a mistake and I think to myself, actually, the version 17 versions back in time was much better. Then I can easily go back and find that version with version control. It's key also to show, you could show people how your thoughts and your code and your project has developed over time. It's a tracking of the history, so it's very good for open science and sharing all that information that someone might want to look at with your project. So it's a very, very useful system to have. So when should you start using GitHub? Now. So start using it now. You can use GitHub as an individual. You don't have to have a team of people around you. You don't have to be collaborating with people. And I say this because often you sort of collaborate with yourself. So the past me may have written some code, and I put it onto GitHub, and I can come back to that code and I can see what I did. I can look at the different versions, previous times, what I changed, what I didn't do, what I tried and what failed. So as an individual, you can actually use GitHub. And I think 90% of my projects are probably individual projects. So I'm not working with a team. You can use GitHub as a team or a lab group. So you can use it to collaborate with others. So we use it in ES Hackathon, so ESMARConf hackathons a lot, because it's a way of collaborating across time and space. So I've seen that Trevor's here online with us today, and Trevor's in the United States, so and I'm in Norway, and other people in the UK, and we're having a hackathon. It's very difficult to actually be at the same time at the same place. But with GitHub, you can make your changes, you can push them up, and someone can look at those changes and review them in their own time. So it's a very nice way of collaboration. If you're a coder, GitHub is a great place. It's a natural place for you to go with your code, to save your code, to share your code, to show everyone how good you are at coding, or that sort of thing, if you want to. So you can make your shop window, sell yourself on your CV with your GitHub thing. But importantly as well, if you're not a coder, GitHub is also useful for you. And I say that because if you think about how sort of a lot of the times maybe it's not just code going up there, it might be a figure from your thesis. It might be part of your thesis, so or a paper that you've written. And using GitHub allows you to track the changes in that paper, but also allows you to communicate with your co-authors, and they can provide information and evidence, extra evidence bits that they want to put in. They can also review your stuff through GitHub. So there's actually a really a strong argument to say that as a non-coder, you also might want to use GitHub. That's probably, I'm probably pushing it a little bit there with that, but yeah, people who are yeah, not always coding is a good start to use GitHub. So in GitHub, there's lots and lots of different sort of terms that get a bit confusing. So I just happen to have written this paper, not just me, a big group of us. And in there, on I think in the introduction in blocks 1, we have a glossary of terms. So the sort of terms I'm talking about is things like repository. We often shorten that to repo.
I'm not seeing the. Can't see that.
Oh, hang on. Yeah, it's the old-fashioned not being able to share the right screen. Can you see it now? Stop sharing. And
yeah, I can see it. Oh, sorry, it's gone. Yeah.
Yeah. Okay. So yeah, you've got the repository, which is we shorten that to repo. So that's your files. There's everything's tracked by Git. As the owner of the repo, you have rights to how you can use it. You can set it up to being public, so everyone can see what you're doing, or you can set it to being private, so only people you want to see it are there. Okay. So on your local system, your repository is also stored, but then you can actually push it up or pull down from the cloud as well. I'll show you how to do that in a minute. People talk about forks and forking, and all a fork is a copy of someone else's repo. So on my GitHub account, if I fork one of Matt Jones's repos, I'll have a copy of his code and everything there, and it will still maintain a link to his GitHub account, his project, but I'll have my own version of it. So I can make changes on my version, and then I could say to Matt, "Oh, I made these changes, pull request," and he'd have a look at that and say, "No, it's rubbish." You can have a fork, which is our local thing. Clone. So cloning a repository is making a local copy of it. So you can clone it, and I'll show you how in a minute, and have your own version. You might not be able to do then, depending on the settings of the owner of the repository, you won't necessarily be able to push up to that repository. So you'd have to do a fork first, and then you can actually interact with that person. Branching is really important. So branching is basically how we make developments in our code, and I'll explain this a bit better in a little while. But it allows us to have a version of our branch, of our main code that we can change. So let's say we find a problem, we want to fix it, but we don't want to make a mistake and ruin the main branch that we've been working on. We want to keep that safe. We can actually separate out our code and work on a particular problem, and then bring it back together again. Okay. That's a really good part of working with code in this way, is that you can actually develop tools or functions that you're not sure they're going to work, but you can develop them, and then you can see whether you can pull them back in. It's useful when you're working with lots of different people as well, to each have their own branch to work from, and then you can try and bring them together, merge them together back into the main. Okay. Another term you might see is commits, and that's probably the most important term. When you make a change on your local version, you commit those changes. And typically you make some changes and you add a message saying, I've made these changes, generated included results in figure. Well, typically I just say made a change, which doesn't help. Don't do what I do. But yeah, you should have a good message. And that basically gives you a timestamp and tells you when, at which point you were. So you can go back in time and look back through the commits and see what's changed at which point. There's not really any sort of great sort of advice I can give you about when to commit, but as often as possible, I think, is the thing. And then pushing and pulling. So when you make commits locally, you want to synchronize that up to the repository on the cloud, and you can push them up. And you can also pull any changes that have been made on the cloud back down to your local repository. A pull request it shouldn't really be called a pull request. It's more like a merge request, but a pull request is where someone else or a different branch wants to merge their changes into the main branch, for example. So it describes what the changes are and has all the code and the testing that someone's done, and tells you whether or not it's can be joined together into your main branch if you want it. So finally, I've mentioned merge already. A release is something that you do by having it's a point in time where you think the product you're making or the code you have is at a point where it's shareable publicly, for example, and you can make that a release and have a snapshot of that repository at a certain time. So if you're doing like a paper or a manuscript that you want to share code with, it's useful to have a release. So that's the first version of the code. There's the second version of the code, and so on. So you can actually have a stable release of code. And finally, the community is a forum for GitHub users to ask for advice. Okay, so somewhere to share ideas and ask for advice. So they're the main terms, and I'll probably say some of them. And if you forget what they are, that table's there. I've linked in the chat to where it is.
And I've also posted the link on Twitter and Slack for those of you following along on YouTube.
Thank you very much.
Yeah, it's on YouTube as well.
Okay, so let me just stop sharing for a second. So what we're going to do now is going to clone a repository and bring to our local version. I'm just sending a funny message. Bring to our local version. And then we're going to make some changes and commit those changes and then see what happens on the system. Okay. So in RStudio, I just have to share the screen again. Sorry, I'm forgetting to do that.
Sorry, Matt, we did have a question on
Yeah.
YouTube. You probably get to it now. In RStudio, how can we launch a remote repo from a local folder, which might be what you're doing now?
Yeah. So I'll come to it in a bit, but yeah, this is what I'll talk about now a little bit. And there's two ways of doing it, but I'll go with the way that I go, but it might not be the best way to do it. So that's the thing. So in RStudio, I think you can see my RStudio now. So here I have, so I may have set mine up a bit different to the way you have, but I've got script file here, my console here, all the files and plots and packages on that side, and then the environment tabs here. Okay. So in RStudio, I can go for a new project, and projects are a way of in RStudio to actually give some structure already to your work. So it's quite a useful thing anyway. Even if you don't use Git, you can use a project. And here you've got three options: a new directory, existing directory, or version control. So I'm going to do version control because that's what we're trying to do here, and I'm going to choose Git. What you can see here, you've got this, it asks for a repository URL. So if we look on GitHub, I have to stop sharing and then reshare again. I don't know how there's probably an easy way for me doing this, but I'll work it out.
Yep.
Let me just find my GitHub.
Matthew, is there anything you want me to help with?
I don't think so. We're okay.
Great, thanks.
Sorry, I'm just trying to find my GitHub account.
If anyone has any questions, just pop them in the YouTube chat or anything.
Okay, so here we have GitHub. So this is the ES Hackathon GitHub account here. So github.com ES Hackathon. And the ES Hackathon has several different repositories, and this is one repository I made the other day. So you can see that I've added a README file, which says test repository for ESMARConf. So if I want to go to this ESMARConf repository, and I want to clone it. So remember, cloning was about bringing it down locally to my own system. So you can see this big green button here that says code. You can actually copy this URL there, copy that. It says copied. And then we go back to RStudio. And I'm going to stop sharing again and move it across because I don't know how to do that. Back to RStudio. And then in the repository URL thing, we can paste in our URL. So we have ESMARConf GitHub. It gives you a suggested name. I'm going to change that because I already have a version of this on there. So I'm going to change that slightly. And then it asks you where to put it. And then you can create the project. Of course, access is denied because I don't know why. Try again. I've been having trouble with my computer the last few days, so it's bound to go wrong today. Check this is going to go. So what it should do is to give you a project and you download everything. I'm just going to test it quickly with another one. I think it's my Git that's causing me the problems. So I'm just going to choose a random repository.
While Matt's trying to solve that, I think we've just had a question on the Zoom chat that I might know the answer to. So I can field that one if you want, Matt, while you're trying to solve that. So Trevor's asked, when starting a new project package, is there a template that covers the basic structure? Or would you potentially clone a repo for a package you know well, or would you recommend starting from scratch as a learning opportunity? So RStudio, when you actually create a new package, does have a basic package structure for R. So it includes the R folder and a basic description file. So that can be a really good starting point. And then you can use things like the use this package to add extras into that package. And for other coding projects, so say you decide to branch out and use something like Node or similar, there's often very similar steps you can take with whatever language you want to have a basic template that kind of initializes a project. It's probably not worth just starting with a completely blank repository and trying to create a package from complete scratch, unless it's quite a simple one. Often these templates are quite useful and generally exist for most languages, including R.
Okay. Okay, I know what the problem is. It's going to take me a few minutes to fix it. Just give me a minute. Oh, I can do this. Okay, so this is typical of these things, that everything breaks when you don't need to. So the problem I'm having is that because of my security system for my IT department, my Git sometimes disappears. So they're trying to fix it, but so hopefully it won't happen again. But so here we have the same thing. I'm using the RStudio server now, so it might look a bit different. The cloning repository from Git. Just get that number from it. and then we want to have EOS hackathon, and it was intro to Git.
We have another question. So
Yeah.
You want to do that now? I've seen some recommendations for a standard file structure or contents for a project repo on GitHub when starting a new project, e.g. meta-analysis. Do you have any recommendations?
So yeah, it's if you're making an R package that's going to go onto GitHub, then there are, as Chris said earlier, there are some recommended or some tools that will help you just build that quite easily. Otherwise, it's really up to you, but I tend to have any R functions in an R folder, and then data folder, and then yeah, some scripts or as quarter or markdown files within it. But it's really up to you. But just the main thing is to try and not have too many big files. There are limits on how big your files can get before GitHub gets upset with you. You have to get quite big, but it's still it's doable. So you just need to be a bit mindful of that and have a logical structure. It's useful in a README if you want to share your repo with other people. It's useful to have a README that says where the important things are and what those things are. So it could be like you have all the R functions are found in the R folder. You can rerun this code using this quarto or markdown file. So it's that sort of thing we can use. So I'm just going to get this to get this. Okay. So I'm creating a project. Okay, so now what we have is the project curated. So this is now my local version. It's actually on the RStudio server. It's my local version of that GitHub repo. So you can see that I've got the same README. It's the test repository for ESMARConf. I've got a thing called the here, which is this is the project file. So this is what R uses. And then you have a file called gitignore. So gitignore is a file, as it suggests, is of the things that Git should ignore. So the things that it ignores there is the R project. So the R project.user. So that's this file here, the R project file, because it's not very useful for it to track changes in that thing. The R history can get very big, so that's probably something you don't really want to include there. And any user data, so things about that are particular to myself that I might not want to share, that's all protected, so it doesn't go through. And you can change that to put anything on there, that list you don't want to make changes. So that could be, for example, if you've got lots of camera trap images and you go through camera trap images, you don't want to share those images because they're quite big. So that I often have this problem. You can actually just put .jpeg on there, and any files that have got .jpeg ending won't be pushed up to GitHub. So that's quite useful.
Yeah, you can also put folders in there, right?
Yeah.
So that might be if all the things you don't want to upload are in that certain folder.
Yeah, it's a very useful thing. So what you'll notice now is I'll just close this. Is we've got this other tab here, the Git tab. Okay. So that Git tab is your tools for working with Git. So we mentioned before about committing, pull, push. Okay. There's the branch you're on. So we're on the branch called main at the moment. We only have one branch. Okay. So we've managed to clone our database, our repo. So what we can do now is to start making some changes and commit them. So if I write something in here, okay, so I've written, this is testing workshop. So I've made a change. Now, if I save that change, doesn't change. She's having a problem, typically. Okay, so this is in the MD. So now we have our, I don't know if you can see the commit window.
No.
No. How do I just share what I'm looking at?
You might need to click the little up arrow, might need to click share screen and just choose the whole screen rather than just the window.
Share that screen.
Yes, there we go.
There we go. Okay, thank you. So this is the commit window. So I've clicked on that commit button in the RStudio window, and it shows me the changes I've made. So let's have a look here. So here I've got the README, and I've added, this is a test during the workshop. Okay, so and it's added a new line. So they're my changes I've made. Now, if I click on that, give it a green tick, it's staged, which means it's ready to be committed. And I can write a message here. Made a change to README to I never write detailed messages, but you should do. And then you can just press commit. Okay. Checking that it's all working. So of course it doesn't like me because I'm on a system that I'm using. Okay. Okay. So we've made our first change. And it's going to take a little while just to wake up again for some reason. Sorry about this. I'm just going to change it, close it again. There we go. Okay, so we've made those changes to the MD file. You can also see there's an HTML file when I looked at it. So we've made some changes. It says here, your branch is ahead of the origin main by 1 commit. Okay, so we've made 1 change. So we've committed. Now what we want to do is to save those changes by pushing them up to the cloud. So we can use these buttons here, pull and push. Now by convention, I always pull before I push, just in case someone is working on the same thing as me and they've made a change. So normally I would pull and then I would push. I'm just going to push now and see if it works. Of course, it doesn't work just because it's one of those days. Again. Here. No. Showing for a second.
So I might just come in here. So GitHub changed the way they did logins. I think it was last year or a year and a bit ago. It's now a bit more complicated than just using a password. So you might have to create what's called a personal access token on your GitHub account, and use that instead of your password. And that will let you log in. Basically, it's for security purposes. So within your GitHub account itself, there is a in your settings, there's a on the password and authentication tab somewhere, there is a way of creating a personal access token to log into Git.
Chris, can you just carry on for a second because I'm just having to.
Yeah. Maybe
do that.
Chris could answer this question.
Oh, where's the question? Always running
in the chat.
small issues. Yes. So, Trevor, in terms of, is that I'm guessing for an R command check to fail, you can actually run your R command check locally prior to pushing it, and that will allow you to sort out, so you can commit your changes or even just have them staged ready to commit. You can run RCMD check locally, make sure that there's no issues and fix it that way. So that's the way I tend to do it. I'll address the RCMD check issues locally before I even push it up to GitHub. So you just run the RCMD check command.
Yes, someone's saying historic Islam on YouTube is saying it's under settings, developer settings, and then tokens. That helps.
Yeah.
Yeah, so I'm still having this problem with Git. I'm just trying to reinstall it.
Oh, that's all right. Yeah, it's in settings, developer settings if you want, and then you just use that instead of a password on the RStudio cloud. So I'll just wait for that to log in. I do find sometimes our command check on Windows, just to address Trevor's point, can be a bit funny because R on PowerShell has another meaning and it starts talking about command histories and stuff. So I can never remember how I end up doing. I always end up having to Google how to actually run R command check on Windows. But I think there's an RCMD check package you can install and run it from directly from within R, which might resolve your issue, Trevor.
Perhaps someone could help me with this question on YouTube. You're talking about adding folders to the Gitignore. How do you write folder path in front of
Oh, yeah. So it would be
the YAML header?
Yeah, so Gitignore. I mean, I'd say you should tune into the advanced GitHub workshop where we cover Gitignore in a bit more detail. But I will post a reply on the YouTube chat, I think, with that.
Yeah,
Probably
bit
less, bit more straightforward to reply. But I'll post a link to the thing.
Yeah, I've put an example there of one of my Gitignores with folders in, but I think maybe I'm misunderstanding.
Okay, so I'm back. So yeah, I've made a different change. I put a change README in there, and I've pushed that up. So this is my local version, and I've pushed it up here, and then what we can see. I'm going to close this one. So now you can see that this is on the cloud. So this is the GitHub repo that docs.g has changed 1 minute ago, and he's added something here onto the README. So I've made that change a couple of minutes ago. So that's how the workflow of sort of making a change and committing and then pushing up to the cloud is done. So the cloning the repository. So another thing we need to talk about really is pretty branching. So let's say that we have this repository here. We have the main branch. So that's the one we want to keep safe, and maybe that's the most important one for us. But we want to try and test something. So we can do this. We can do in RStudio. See this funny symbol here? This is the branching symbol. So we can do a new branch, and we can call it mat and add. Okay, something like that. So we can create this branch. So what it's doing at the moment is copying the main branch and then giving a new branch. And you can see here we're in this new branch called mat add r. So in here, what I'm going to do, I'm going to add a folder. I'm going to call it the R folder. And then inside that folder, we're going to write okay, and our function. Okay, so we've got written a function called a silly function that will print this is a function. Okay, completely useless function. We're going to save that in our R folder. And then so we've made a couple of changes now. We've added an R folder, and we've added an R script within that folder on this branch. Okay. So I'm going to commit those changes. You can see here the R folder, the R there, and the silly function. And then we're going to commit those changes. add our folder. Okay. I'm going to be good. I'm going to pull first just to check that there's nothing been changed. It's already up to date. That's great. I'm going to push. Okay, so that's been added up. So we can double check that by looking at our repository. So now we have another branch. So we have the main branch and we have Matt Adar, which has been updated by me now. Okay. So now we have two versions of the same repo, but one with a different change in. Okay. So let's go back to RStudio and I'll show you how that looks. So now on my local files, I've got this extra folder R with the city function in. So if I go to my files, yeah, I have to dig through thousands of files, sorry. Here we go. So this is my local folder. This is my local on my computer folder. And you can see here that we've got a folder called R, and inside there we've got this silly function. This is what really sort of blew my mind when I first started using Git. And I know it's really stupid, but it's not that exciting. But okay, are you ready? It's like a magic trick. Okay, if I switch back to the main branch, so we switch back to the main branch. I'll close that now. And let's first have a look here. I'm just going to minimize myself. Okay. As if by magic, the R folder has disappeared. Okay, it's not there anymore. So if I go back to our folder here, the main folder, you can see that the R folder itself is gone. Okay. So what it's doing is switching. When you switch branches, you actually switch all the way through your local system as well. So that's something that you, yeah. So sometimes I end up panicking because I can't find something I knew I've done, but it's because my branch is the wrong branch. Okay, so it's something to remember if you like me and sort of quite easy to panic about things. But yeah, so that's something you can do. So now we can make changes within our. So let's switch back to our branch. Okay, I'm gonna close that. So let's say that, so you can see now that R is back again. Okay, with our silly function. So let's say that we want to merge our silly function in with our main branch. So from our add R branch to our main branch, we're going to have to do that. Well, we can do it through R, but the easiest way is through GitHub. So we go to our GitHub site, and you can see here that very usefully it says that Matt add R has some changes recently. So I'm going to do a pull request. So a compare and pull request here. You can click on that, and then what it's going to do is going to check first of all if these changes are compatible with the main branch. So you can see here it's got this big green tick, they're able to merge. So it means that we don't have something they call merge conflicts. Merge conflicts are the bane of my life, and they're quite annoying. So that's where two people or you have made two changes that conflict each other. So maybe on the same line of code or in the same file that means that they can't be joined together, and you have to try and sort out the mess. But here we're okay, we can merge that. So this is add R folder and silly function. Okay, so I would like okay, so I'm going to then create a pull request. And there's some automatic checks that will just check whether there's any conflicts again. You can see what changes have happened here. As I said, there's no conflicts here, so we can actually merge this pull request. So when we merge this pull request, what's going to happen is that from our branch, we'll move across to our main, and they will be synchronized again. Okay, so I'm going to confirm that, merge, and it's merged. once it's merged, you can delete that branch if you want to. It only deletes it on the GitHub. It doesn't. So you can delete it here. And then if you realize, oh no, I shouldn't delete it. Or you can just use your local branch and push it back up again. Okay, that's not a problem at all. So you can have those different branches. You can use them. And you can see here that now, if I go back to the code, we have an R folder, we have our city function in there, and it's all in our main branch. So let's go back to RStudio again. Okay, I'm going to switch to the main. Okay. But look, here we don't have our R folder. So what we have, this is why I say it's important to remember to pull before you push. So it's here what we need to do is pull those changes from the cloud back into RStudio. And they're saying this added this R city function, R folder. And then you'll see that now on our main branch, so on the main branch, we have an R folder with a city function. Does that make sense? And can you see the use of it outside of a silly idea, or do we need to explain a bit more about the reasons why we do this? Do you think?
So pulling is like downloading, pushing is like uploading, and yeah, branching doesn't have. Branching is like creating a different version of your current folder, but you're not actually having to copy it. You just sort of create a ghost of it, which then gets merged.
Yeah, I mean, there's a lot of these sort of terms that are sort of a bit confusing, but just really just remembering that there's Git sort of has these terms with things like pull, push, merge. They're quite straightforward once you know what they mean.
So all those the hidden change, the changes, the history of change, is that stored in the .git folder?
Yeah.
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 And that's like an invisible file on some computers, isn't it?
Yeah.
Yeah.
So it's sometimes hard to find that, but it is there.
Yeah. Not just magic.
So if you're feeling brave and you fancy having a go, you can fork the repository. So if you, as long as you have your own GitHub login, you can go and you can fork. So on the, no, I'm not sharing the screen, sorry. In this screen. So on this repository here, we can press fork. So it asks me where I want to fork it to. I'm going to fork it to myself here, and then I can create a fork. So this fork is now my own version of that repo that belongs to ESMARConf. So you can see here it says fork from ESMARConf. Now there's a few things that are really useful and they're quite new. So because this is my own version, any changes I make here won't necessarily be able to automatically link up to the other site, because basically you're taking a copy of someone's code and you want to make changes to it for yourself or for them, and you want to contribute to the project. So what you can do is you can sync your fork. So this won't happen now because everything's the same, but you can sync your fork to get the changes that they've made into your fork, or you can contribute. So that allows you to do a pull request from that fork. Now the process would be the same of getting this into your local version with the RStudio, going onto the code and cloning it down into the RStudio project. Okay, exactly the same way. but this time it will be in your name and not on the ESMARConf site. So if you have if you have a GitHub name and you want to try that, please do. You can try and try and fork the, I'm going to get myself confused here, fork the GitHub repo from ESMARConf, and then get it into your local site. Then use the code button to clone it down into your project, your RStudio projects, and then you can make changes and then see how that happens. Any pull requests would probably be ignored, but we can have a go. So yeah, feel free to have a play around, and the same with any of my repos. You can fork them, or that's not a problem. That's, people expect that, so there isn't really a any problem. The etiquette usually is just that if you're forking someone's work and you want to make changes, then it's good to actually suggest those changes to them to make so if you think that something needs to be changed. But it's fine to just copy someone's work. I often do it for papers and things. If someone's got a repo and they have all the code on GitHub, I'll fork their repo and have a look at how they've worked it and maybe get some ideas for myself how things work.
Okay, so that's forking. Just to previously you introduced merging.
Yeah.
We had a question on merging. It was, what do you do in the case of a merge conflict?
Okay, so merge conflicts are sometimes fun and sometimes horrible. So yeah, with a merge conflict, what happens is that when you go through that process of a pull request, it'll say that it cannot merge, which doesn't mean that you can't do the pull request, but it means that you have to make some changes. What it'll do is actually show you the versions side by side or next to each other, and it'll show you where the differences are. And then you need to decide which difference you want to take forward. Do you take the latest version or further on? So these processes allow you to sort of check what is the right code to do. So that's why I would say commit quite regularly, so you avoid having these massive merge conflicts, because that could be very, very painful to play with. But having a few lines of code to have a look at and then double check, that's okay. And then once you've cleared those conflicts, if you have them quite small, you can do it within GitHub. If they're larger, you have to do them within GitHub desktop or in RStudio sometimes. But usually only for small ones. You can actually just do them in this area here, and it allows you to see the different code. So it's a very useful way of sort of having an overview of what the changes are, and then making and confirming which changes you want to keep. So it's actually quite a simple process, but keep your changes quite small to start with. Don't do anything big that will take days and days of work. So commit every day at least, maybe more times during the day. I don't know if you guys have any sort of rules of thumb for committing, how often you do it.
I think it for me it depends what I'm doing and the kind of project I'm working on. I tend to commit to a fork probably quite regularly, but I try and make sure that each commit works. So I don't like committing half-finished functions because I find that a bit annoying. But that's just me.
No, there's a T-point.
Someone's asked about getting back to old branches that have been deleted. That's on YouTube, I think, about, and I'm guessing it means deleted remotely and locally. If it's deleted on one or the other, it's relatively straightforward. And I guess if are you able to just demonstrate how you can get back to a different branch if it's gone, if you've removed it from GitHub?
Yeah. So again, press the wrong button. So on changes that have happened, long list, and then we don't have that branch anymore. So all those are gone. We need to go back in time. Yeah, I'm looking in the wrong place. That's why it's confusing me. Yeah. So we can see all the commits we've made over time. So we've made 4 commits here, and we can actually click on any of these and restore them. Just do this. Okay, so that's what the changes we've made in the past. So we can always go back in time to actually find the things, and I can't find where it is now, just to really be annoying.
Oh, to go back to the branch.
Yeah.
I think if you've deleted the branch, you might have to. It might be under the main. If you click on the main, it's probably gone now, hasn't it? From there.
Yeah.
But what it'll be is it'll be on your local.
Yes.
And then you can push it back up.
Yeah.
Because you've got the local branch there, Matt Adar.
Yeah.
You should be able to push that back up.
Yeah. So now the branch is back.
And if you've deleted it locally and remotely, it's a lot more complicated, and you have to delve into the command line.
Yes, and that's the advanced part of the world. Yeah. So I think with GitHub, there's nothing you can do wrong, and you can't. So well, there's a lot of things you can do wrong. You can't really destroy everything unless you're very unlucky by mistake. But there are some commands that you might need to find out how to do. There's a great site, and it's called something like, I'll have to find it for you, something like "Oh shit Git," and it's where you make the common mistakes that happen and how to solve those with the command line. So that's quite a useful site to find if you get into trouble. But basically you can't really make too many mistakes on this. In RStudio, you can see all the history. So these are all the things that have changed. As README, I've changed the name of the README. Added the R folder and the city function. They're all on there. So you can actually get back to all the commits you had before, and it gives you a little code here. And this is one of the codes where you need to have in the command line. You'll need that code to go back in time to that point. So that's the unique ID for each of the changes you make. So that's where that information is in RStudio. So if you see something asking you about the SHA code, that's the code you'll need, which is in the history part.
We have another question. You done with that one?
Yeah.
Yeah. It is. I'm not sure I fully understand. Is there a way to commit and test a change without pushing? How does that work, and what is the best practice steps?
Yeah,
I guess branching.
Yeah, definitely. So it's branching. So you don't have to. You can make a branch. You don't have to push it up to GitHub. So if I want to have a branch that I keep locally, that I don't make changes to, that I make changes to, that I'm just working on locally, that's fine. but it's good practice, I think, to actually push it up to the cloud, just in case your computer dies or you have a problem with your Git, like I did a minute ago. Those things happen, and they happen quite regularly, or your computer gets run over by an elephant or whatever it might be. Those things can happen. So I would always have, I often call it mat development or mat dev branch. So that's anywhere I'm messing around with stuff that may not work, might be stupid, but I have this branch. There's no cost to having lots of branches. There's no real problem with having a lot of branches on there. So you have 15 different branches looking at different aspects of your code, and that's fine. It gets a bit complicated when you're trying to merge everything back together and which parts to merge, but I mean, that's up to you really. But I would make a new branch, have it as a development branch, and then make the changes that are of interest to me in there.
Yeah, I think that's quite a common approach in software development, is that you have a development branch, and then usually there'd be multiple people involved, and they would then test whether that development branch functions as intended, and then we get merged into the main branch, which is like the working version of the software. That's another analogy.
Yeah. Okay, so I'm going to talk a bit more about the sort of some of the features that you can use within GitHub that are useful when collaborating on projects. So this is a project that's about the ecological condition of of Norway. So it's a large project that we have in Norway, and this is a documentation of our code and how we did make the calculation for ecosystem condition in Norway. And what we're doing in this project is we have 3 code reviewers, and then we have maybe 15 or 16 experts who work on different aspects. So it could be they're an expert in threatened plants, they're an expert in forests, they're an expert in mountain habitats. And none of those guys are really coders, but they do have some understanding of code, but they're not necessarily coders. And what we have is 3 people who are code reviewers, myself and 2 others, Anders and Hanno, who are coders. And then we ask people to upload their code to this site. So when they've done that, we get this pull request. Okay. I show an old one. So in the pull request here, this is for Fremede arter, which is like non-native species. And there's Anders has made these changes here. And what you can see is that you have this review tab. So he asked for some reviewers, myself and Hanno, to have a look over the code. We can actually look at all the stuff that he's changed. So just go down to so these are all the different files he's added in and how it's changed. Large difference here. So these are the files he's added in that process. And what we can do is we can actually do back to the wrong place. So we can discuss different changes. We have information back and forth. So it's really useful communication tool to actually talk about the code and how it changes over time. And this is all documented and kept, so we know what's been changed. Go back here. We reviewed it. So there's a process here, a reviewing process, that it shows you the changes that happen within a file. So the green one is the changes, and the red ones have been deleted and changed. The green ones are the additions. So what we can do, we can go through and review these changes. Here, we can leave comments. We can add comments to a particular line, for example. So that would add to that line. And any changes that are made are all documented. So this is really useful if you're working on, for example, a manuscript in Quarto or Markdown, and you can go through each line and you can see, well, there's a mistake there, add a comment, and then the person will get a notification that there's been a comment added on, and then they can make the changes they see fit. That's a really useful tool, really helpful tool for assessing things. And when you do a pull request, you can ask for certain reviewers. So you can tag a reviewer. So if I make a change to Matt's code, I'll ask him to be a reviewer on that. And I might ask Chris as well, because he's really good at code. So add those two reviewers on, and they'll get a notification, and they can come and look at the code, and they can agree or disagree, or they can argue about it. They can say, maybe you should use this approach, but not that approach. So it's a very, very useful tool, very helpful tool in there to make changes. The other tools that are really useful within GitHub are things like the issues. So issues are things where something needs to be changed, or there's a bug, there's a problem. Okay, there's something not working. So for example, here we've got a bug. So we have a description of what the bug is. There's a problem with the template for the indicated chapters. Okay. And then we have someone who's assigned to do that work and make a change. In this case, it's me. So there's description of the problem, and then some extra bits and how it's linked to other things. And then he assigned it to me to work on. So that's my job to fix this problem. And when I fix it, I can close this issue. I haven't fixed it yet, so I can't close the issue. But that's how to use issues. So they're very sort of issues I see normally as sort of something directly about the code, something that's really focused on the code. This discussions tab is quite new. Discussions that I see are more broadly, maybe about the project in general, or there's lots you can add in there and discuss. So it's a longer form, broader approach, and it's not necessarily just directly about the code, but you can turn discussions into issues, and you can link issues and discussions points together. Okay. It's quite a useful tool, I think, to have. Yeah. So any of you can download this code, have a look at it. You can work through and see what's there. So the code on this site, and anyone, we welcome anyone to do pull requests. So if you see a mistake in our code that you think is an issue, you can highlight that. You can send it. You can write an issue, say where the problem is, and you can also make a change on your local version, and then do a pull request over to us to see, if we agree with you or not. And that's basically how this collaboration often works with other people, is that you write an issue, you find a problem, you then write a pull request, so you fix that problem, and then you send that pull request to the owner of the repo, and they either decide to make the changes themselves or to use your changes and make you a contributor to the project. So it's quite a collaborative way of working. So let me just, do you have any more questions, Matt?
Nothing at the moment. No.
Okay.
There was that one from earlier I could bring up again. Can we generate a remote repo from a local folder in RStudio?
So can we make a, sorry?
Remote
yes.
repo from a local folder in RStudio.
Yes. So you can, in the use this package, there's a way to create.
Your screen isn't showing at the moment.
Okay, that's I need to find the actual one anyway, so that's fine. I don't remember what the thing's called. Local. The use this package is really cool. It's got loads of really helpful functions in there, and fairly recently they've started to put up functions for interacting with GitHub. So use GitHub, takes a local project, and then pushes it up to your GitHub, your personal GitHub site, and it creates a repository. So it's a really good way of taking a local repository and then moving it up, as you say. Typically, I don't use this approach because it's fairly new, but I think it's yeah, I think it's something that increasingly I will do. But normally I start the process by starting with a GitHub repo, just a blank one, and then starting a new project locally and linking them up using the code, the URL for the code, linking them up together, and then doing it that way. But yeah, this use this package allows you to go the other way as well. So if you started with a project a while back and you just want to add it up to GitHub, you can do it this way. In the command line, which Chris will talk about later, there's even an easier way to do this, and GitHub itself tells you what to write in the command line. So when you initialize a new repository, I can show you on here. Go to my own site. I'll do a new repository. Okay, and create a repository. So here, so this is the code here. So I could either use this code as I showed you before. So that's the same as that green tab, or I can use the command line. Well, this is the one that we're talking about here. Is we'll push an existing repository from the command line. So if you have an existing repository, you can actually use the command line and use these commands here to actually push your repository up to this site. Okay, so that's another option, is setting up the GitHub like I've done now, a new repository, getting to this page, and then using these commands here in the command line, which Chris will talk about later on, the terminal or command line, and that allows you to do that process. So that's quite a useful tool.
You do have to have it has to be an existing Git repository to do that, but that's as easy as one command. If you type git in it, as it says there, if you've got any folders in there, you just need to add your files and folders. So git in it, git add -a, and you're good to go.
Yeah, so it's quite a straightforward process.
But there's nothing in the graphic user interface on RStudio. So
yeah, if you want to do it using the use this package, then it's just writing code into RStudio, as long as you have a GitHub name, so GitHub site, and as long as you have the right token all in there, then that's fine. It just pushes everything up. Yeah, or there's this approach using the command line. So I found that there can be sometimes it's a bit tricky with the use this. Sometimes it works really, really well, and sometimes it doesn't work at all. Yeah, so yeah, as I say, my repo, and then yeah, starting the whole process that way.
Yeah, it's probably one of those things that's going to be ironed out, and eventually it'll be incorporated into RStudio.
I think so. Yeah.
So there's a button.
Yeah, definitely. I think mainly the thing with Git and GitHub is just trying. As I said before, you can't really break it. If you do break it, then you'll be very sort of famous, because it's very hard to break. But don't be frightened of it. Don't be frightened of using Git and GitHub. It's a great tool for collaboration. So a lot of the work that probably the best fun I've had is collaborating through GitHub. That makes it sound very sad, doesn't it? But some of the best work I've done is collaboration through GitHub. So the paper I wrote with my colleagues from Sorty on GitHub, we actually did the whole process, the whole manuscript using GitHub, using something called ManuBot, which is a GitHub manuscript repo. So you can just clone that repo, and then you can write your own personal manuscript in there. It's really good. It's really a great way of working. Yeah, so it's not just code. It can be manuscripts. It can be websites. It can be anything. You know, it's quite a versatile thing. The one thing I haven't mentioned really is this the GitHub Pages, which is a very easy way to make your own website. So there's lots of help out there, particularly now there's Quarto, with RStudio. If you're using Quarto, it's very easy to make a website which you can host on GitHub Pages. So each repo has its own GitHub Pages site. I'll just show you a quick example because we've only got a couple of minutes left. So let's go. Delete that later on. Yeah, so you can have for each site, you can have each repo, you can have a GitHub Pages site. Go here. So this is the repo for my website, and then this is the website here, bigger. So it's very simple. It just has a picture of me, a picture of a pheasant because I like pheasants, some information about me, and then my publications listed here. It's a very simple thing, but all that is coded with R using Quarto and hosted on GitHub Pages. So it's a really useful tool to have. It makes everything a lot easier to have it there. I can make changes locally to my within R and then push them up, and the changes are done in a couple of minutes. So it's very useful.
I've just found out the newest version of RStudio does let you actually create a GitHub account for a GitHub repository from an R package that you've already created. So I'll just very quickly show you that.
I called it, didn't I?
In 1 minute. So yeah, so in your RStudio package, hopefully you should be able to see my screen. I'll just share my actual whole screen because I realized it won't show you the thing we've already. So hopefully you can see my whole screen there. It's as simple as tools, version control, project setup, choose Git, click yes. It'll restart RStudio, and then hopefully come back with it being a Git repository.
Cool.
So give it a second. There we go. And that's now a Git repository.
Wow.
And then you just it's simple as you'll need to go back into project setup, or you'll need to try and push it, and it'll ask you for the GitHub URL to put in as your what we call origin. But there we go. That was less than a minute, and we're bang on time for finishing.